Hello everyone, I welcome all of you again in my next online class. So today is, I guess it's ninth lecture of heat and mass transfer. So before I start this today's ninth lecture, I'd like to revise the concept or lessons of previous classes. So in our previous classes, we discussed on heat, we discussed on temperature, we discussed on conduction, we discussed on convection, radiation. So in conductions, we follow Fourier's law of heat conduction, Q equals to minus K into A dt by dx. In convection, we follow Newton's law of cooling, Q equals to H into A Ts minus Tf. And in radiation, we follow Stephen Boltzmann law, Q equals to sigma A epsilon T1 power 4 minus T2 power 4. So this all we discussed. Then we have followed in conduction mode of heat transfer, general heat conduction equation for Cartesian coordinate, in cylindrical coordinate and in spherical coordinate. And based on this, we calculated the heat transfer through slab of one dimension without heat generation and steady state. The value is Q equals to K into A T1 minus T2 by L. Then we calculated amount of heat transfer through cylinder without heat generation and steady state one dimension. The value is Q equals to K 2 pi KL into T1 minus T2 by ln of R2 by R1. And in sphere, the value of heat transferred through one dimension steady state and without heat generation, the value is Q equals to 4 pi K R1 R2 divided by T1 minus T2 by R2 minus R1. And last, we have seen the composite slab. So for composite slab, the value of heat transfer is Q equals to A into T1 Ti minus T naught divided by 1 by Hi plus L1 by K1 plus L2 by K2 plus L3 by K3 plus 1 by H naught. And overall heat transfer coefficient U value, U equals to it was 1 by Hi plus L1 by K1 plus L2 by K2 plus L3 by K3 plus 1 by H naught. And for composite cylinder also we calculated amount of heat transfer Q equals to Ti minus T naught by 1 by HiA1 plus ln of R2 by R1 by 2 by K1L plus ln of R3 by R2 by 2 by K2L plus 1 by H naught A2. And then overall heat transfer coefficient based on inside UI equals to 1 by Hi plus R1 into ln of R2 by R1 by K1 plus R1 into ln of R3 by R2 divided by K2 plus 1 by H naught R1 by R3 H naught. And overall heat transfer coefficient based on outside U naught we got here 1 by R3 by R1 into Hi plus R3 ln of R2 by R1 divided by K1 plus R3 into ln of R3 by R2 divided by K2 plus 1 by H naught. So up to this we discussed. Now today we'll start composite geometry of spherical body or for sphere. Amount of heat transferred through composite sphere. Now today we will calculate. So for this again we have to just visualize the picture. So here you can see the diagram. Just try to visualize the picture here. So here you see you have two spheres. One sphere has inner radius R1 and outer radius R2. In the second case, in the second sphere, you have inner radius R2 and outer radius R3. And inside of the first sphere, you have air, and outside or beyond the second sphere, there also air is present. So this is about the picture. So in picture, what you have? First, inside the first sphere, air is present, then you have two sphere. One sphere has inner radius R1, outer radius R2. Along with the first radius, you have second sphere. You have inner radius R3 and outer radius R2. And beyond the second sphere, you have outside air or ambient air is present. Now here also you take the assumption that Ti is more than T1 is more than T2 is more than T3 is more than T0. So obviously from high to low heat transfer occurs. That means from inside to outside or outside to inside heat will flow. Yes, from inside to outside heat transfer occurs. So you see there are two spheres are available. Inside the first sphere there is air and outside the second sphere air is present. Inner radius of the first sphere is R1. Inner radius outer radius of the first sphere is R2. Inner radius of the second sphere is R2 and the outer radius of the second sphere is R3. So we can write at R1, R2 and R3 radius the temperature of sphere is T1, T2 and T3, and inside air temperature is Ti, outside air temperature is T0. So this is all about the diagram. Now you tell me from where to where heat transfer? Yes, from inside to outside. Now how this heat transfer occurs? So first heat will be transferred from inside of the air to the first sphere. Then heat will be transferred through the first sphere. Then heat will be transferred through the second sphere. And last, heat will be transferred from second sphere to the outside air or ambient air. So you can write here heat flows from inside air to the first sphere, then through first sphere, then through second sphere, and the last from second sphere to the ambient air. So first, what is the heat transfer? From inside air to the first sphere, means from Ti to T1. So what is the mode of heat transfer? Obviously this will be conduction, convection or radiation. Yes, it will be convection. Why? Because air is the medium and it's a gaseous body, so that's why medium is gaseous, means convection mode. In convection mode we follow the Newton's law of cooling formula. So Q1 equals to Hi into A1 into Ti minus T1. So here Hi is overall convective heat transfer coefficient on inside. So Ti minus T1 we get here Q1 by Hi A1. So through first sphere, then what is the formula? It will be from T1 to T2 and the mode of heat transfer will be your conduction. So Q2 will be, so now tell me what is the amount of heat transferred through sphere? Already we calculated Q equals to 4 pi k R1 R2 T1 minus T2 by R2 minus R1. Now as per nomenclature, if I replace the values, so Q2 will be 4 pi. So for the first sphere, thermal conductivity of the first sphere is K1, so that's why 4 pi K1. And for the first radius, inner radius is R1, outer radius is R2, so I can write 4 pi K1 R1 R2 into T1 minus T2 by R2 minus R1. So T1 minus T2 we can write here Q2 into R2 minus R1 by 4 pi K1 R1 R2. Now through second sphere means from T2 to T3, again it is a conduction mode because it's a spherical body, solid body. Now in conduction mode of heat transfer for spherical body, the formula we know 4 pi k R1 R2 T1 minus T2 by R2 minus R1. Now as per nomenclature if I replace, so Q3 becomes 4 pi. So thermal conductivity of second sphere is K2. So 4 pi K2 R2 into R3, because in the second sphere we have inner radius R2, outer radius is R3. So 4 pi K2 R2 into R3 T2 minus T3 by it is R3 minus R2. So we can write T2 minus T3, we can write Q3 into R3 minus R2 by 4 pi K2 R3 R2. And same way heat transfer from second sphere to air, means this is from T3 to T0. Now this is the convection mode because air is the medium In medium air convection mode, we have to follow Newton's law of cooling. Q equals to H naught A2 T3 minus T naught. So what is H naught? Convective heat transfer coefficient outside. And what is A2? A2 is the outside of the spherical air. Area of the outside sphere. So here also you can write T3 minus T naught equals to Q4 by H naught A2. So now if I add these all equations, then we can write Ti minus T1 plus T2, T1 minus T2 plus T2 minus T3 plus T3 minus T naught equals to Qi by Hi A1 plus Qv2 into R2 minus R1 by 4 pi K1 R1 R2 plus Q3 by into R3 minus R2 by 4 pi K2 R3 R2 plus Q4 by H naught A2. Now again we have to take the concept. So amount of heat transfer throughout the each and every step, means from air to the first sphere, through first sphere, through second sphere, or maybe from second sphere to the air, amount of heat transfer will remain same, because you are not considering any terms of heat loss or any terms of heat accumulation. So whatever the heat transfers from first sphere to the second sphere, or through the second sphere, or maybe from sphere to the air, the heat transfer remains same. So I can replace the Q1, Q2, Q3 and Q4 values with heat transfer Q. So we can write Ti minus T naught, Q you take common, so we can write 1 by HiA1 plus we can write R2 minus R1 by 4 pi K1 R1 R2 plus R3 minus R2 by 4 pi K2 R3 R2 plus 1 by H naught A2. So overall heat transfer Q equals to, it becomes Ti minus T naught divided by 1 by HiA1 plus R2 minus R1 by 4 pi K1 R1 R2 plus R3 minus R2 by 4 pi K2 R3 R2 plus 1 by H naught A2. So this is the amount of heat transfer through spherical body or sphere product. Now we have to use the overall heat transfer coefficient concept, that is Q. Now you tell me, in this time, can you take the overall heat transfer coefficient concept? Yes, you can't take directly U concept. Why? Because the area of each and every spheres cannot be same. You can't assume that area of each and every spheres are same, because we know the formula of area of sphere is 4 pi r square. So here you see you have the radius or r term you have. That means area of the inner sphere will be 4 pi r1 square. Same if you want to calculate area of the third sphere, second sphere, then we have 4 pi r3 square. So area of each and every spheres are not same. That's why you can't take the overall heat transfer coefficient concept. So that's why you have to do a modification on this concept. So we have to take overall heat transfer coefficient based on either inside or outside. So let's begin with this overall heat transfer coefficient based on inside. The formula already we know, Q equals to Ui into area. Now which area you will take? So already you are taking inside, so that means you have to take inside area, means A1 multiply overall heat transfer, means the potential will be overall, so it is Ti minus T naught. So we can write, if we compare these two equations, then we can write Ui into Ai, Ti minus T naught equals to Ti minus T naught by 1 by HiA1 plus R2 minus R1 by 4 pi K1 R1 R2 plus R3 minus R2 by 4 pi K2 R3 R2 plus 1 by H naught A2. So we can write Ui equals to 1 by, so I'll take this A1 in the right hand side. So I can write A1 within bracket 1 by HiA1 plus R2 minus R1 by 4 pi K1 R1 R2 plus R3 minus R2 by 4 pi K2 R3 R2 plus 1 by H naught A2. Now if you take this A1 in the inside the bracket, if you remove the bracket, then we just put the values, and we know the value of A1 is how much? 4 pi r1 square, and value of A2, that is outside radius or outside of the sphere, we have the value 4 pi r3 square. So if we replace it, so it becomes qi equals to 1 by ai by hi a1 plus a1 into r2 minus r3 by ln of 4 pi k1 r1 r2 plus 4 a1 into r3 minus r2 by 4 pi k2 r3 r2 plus a1 by h naught a2. So finally we get ui equals to 1 by hi plus 4 pi r1 square r2 minus r1 by 4 pi k1 r1 r2 plus 4 pi r1 square r3 minus r2 by 4 pi k2 r3 minus r2 plus 4 pi r1 square 4 by 4 pi r3 square h naught. So finally we get ui equals to 1 by hi plus r1 into r2 minus r1 by k2 r2 plus r2 square r3 minus r2 by k2 into r3 r2 plus r1 square by r3 square into h naught. So same way, if we want to calculate the overall heat transfer coefficient based on outside, then we can write Q equals to U naught into A2 Ti minus T naught. So if we compare these equations with overall with the heat transfer of composite sphere, then we can write U naught into A2 Ti minus T naught equals to Ti minus T naught divided by 1 by Hi A1 plus R2 minus R1 by 4 pi K1 R1 R2 plus R3 minus R2 by 4 pi K2 R3 R2 plus 1 by H naught A2. Now this Ti minus T naught, I can cancel these two terms from the left and right hand side, and A2 term in the left hand side I can take it in the right hand side, so it becomes 1 by A2. So I know the value of A1 how much, 4 pi R1 square, and the value of A2, that is the outer area of the sphere, 4 pi r3 square. So if I put the values, then it comes finally u naught equals to 1 by r3 square by r1 square hi plus r3 square into r2 minus r1 by k1 r1 r2 plus r3 into r3 minus r2 by k2 r2 plus 1 by h naught. So before I finish this class, I'd like to revise the today's class. So today we discussed about the heat transfer and overall heat transfer coefficient based on inside, based on outside of spheric or composite sphere. So we know the heat transfer of sphere, of single sphere. The formula is 4 pi k r1 into r2 by into T1 minus T2 by R2 minus R1. But if you take composite sphere, then overall heat transfer becomes Q equals to Ti minus T naught by 1 by Hi A1 plus R2 minus R1 by 4 pi K1 R1 R2 plus R3 minus R2 by 4 pi K2 R3 R2 plus 1 by H naught A2. And if you take overall heat transfer coefficient based on inside, then Ui becomes Ui equals to 1 by 1 by hi plus r1 into r2 minus r1 by k1 r1 k1 r2 plus r1 square into r3 minus r2 by k2 r3 r2 plus r1 square by r3 square into h naught. Same way, if you want to calculate overall heat transfer coefficient based on outside u naught, so u naught equals to 1 by r3 square by r1 square hi plus r3 square into r2 minus r1 by k1 r1 r2 plus r3 into r3 minus r2 by k2 r2 plus 1 by h naught. Okay, thank you.